Hi, everyone, and welcome. Thank you all for joining this webinar. My name is Ash Musa. I'm on the Bitbucket marketing team. I'm joined today by Riley Venable from our partner Atlas Bench. Riley has been a solutions architect for over a decade and has helped over 50 companies manage their core and CI/CD workflows on the Atlassian platform. We also have Warren Marusiak, a senior developer evangelist on our team. Prior to Atlassian, Warren was a developer at AWS. Warren focuses on creating content to show our customers how to build developer workflows on the Atlassian platform. A little bit of housekeeping before we begin. On the right, you'll see a Q&A window. Ask us questions here during the webinar. We'll answer what we can via chat, and we'll take other questions live after the presentation. There's also a resources tab that you'll see, which will include some links that we'll reference during the talk. And this webinar is being recorded. You will get an email with the recording link and all the links in the resources tab as well in a day or two after today. So let's move on to the agenda. I'll start off by highlighting some of the challenges with Jenkins and how Bitbucket pipelines can help overcome them. Next, Riley will walk through a migration case study. He'll share the process and go deeper into the impact on costs and developer productivity. And then Warren will do a demo of our recently launched Jenkins to pipelines migration CLI tool. And finally, I'll wrap up with a few highlights of what's new in Bitbucket pipelines, and then we'll move on to a Q&A. So let's talk about some of the challenges with Jenkins. For some context, for many years, we ourselves at Atlassian were using on-premises CI/CD tools like Jenkins and Bamboo. We've been gradually moving to Bitbucket pipelines over the last couple of years. Today, our 9,000 plus person engineering org relies on Bitbucket pipelines. As many of you know, Jenkins is a legacy CI/CD tool. It was one of the first CI tools to be available in the market, and it became popular because it was open source and it was flexible. It offers a huge plugin ecosystem, which allows it to meet the needs of a diverse customer base. But today, these same strengths have become weaknesses, and we felt this ourselves and heard this from so many of our customers as well. First, Jenkins itself may be free, but it comes with high overhead costs to maintain. Each time you need to scale up, you need to configure a new server. And then to manage your costs, you may be investing in automated processes to scale these servers up or down during peak and off-peak hours. And adding on to the costs of an overhead is plugins. With Jenkins, there are so many plugins to install and maintain that it adds to your overhead costs. And in terms of developer experience, developers have to jump between tools frequently, chase down build issues, and rely on operations teams to keep things running. Now, here are some ways in which Bitbucket Pipelines helps you overcome these challenges. These are the same reasons why we at Atlassian switched to pipelines as well. First, Bitbucket Pipelines is a fully managed CI/CD tool, so you don't have to worry about overhead costs to manage servers or scaling up or down. You're using Atlassian's infrastructure, which scales on demand. There's always an agent available for your build, and developers don't have to wait around for their builds to run. And you only pay for what you use. Next, Bitbucket Pipelines is easily extensible. There's no more plugin sprawl. Our pipes extensibility framework lets you integrate services like testing, security, and others with just a few lines of code with nothing to install or maintain. There are no security patches and such either because Atlassian manages these for you. All you do is paste in the snippet into your script and you're good to go. On the developer experience side, Bitbucket Pipelines is built into Bitbucket Cloud, so it's seamlessly integrated with all your repositories and your Atlassian tools. So your code status can be easily linked to Jira issues, and your deployments can be set to flow into Jira Service Management to integrate with any change management policies that you might have. And developers can see real-time pipeline status, so if something breaks, they can fix it and get to production faster. Next, I'm going to hand it over to Riley from Atlas Bench to share a case study which will bring some of these benefits to life. Atlas Bench is an Atlassian certified solution partner. Last year, they were recognized as Atlassian's Software Development Partner of the Year in the Americas region. They specialize in helping customers implement Atlassian cloud tools and also offer migration services to help customers move from on-prem tools into the cloud. And with that, over to you, Riley.
Thanks, Ash, and hi, everyone. Let me give you the background on the case study. We worked with a US-based logistics company managing 1,000 employees with 200 developers. They had 95 repositories supporting their entire logistics operation: fleet management, route optimization, warehouse systems, and customer portals. Their setup was Bitbucket Data Center for source control, paired with a sophisticated Jenkins infrastructure running on Kubernetes, while their entire operations teams were already using Jira Cloud. The infrastructure burden was significant. They're managing Jenkins controller plus 20 always-on Kubernetes worker nodes running 24/7. Here's the key issue. Those nodes were idle about 60% of the time, but they're paying for them around the clock. This was kind of an optimization trap. They faced a tough choice: keep paying for idle capacity or hire someone to optimize it. Either way costs money. Optimizing the infrastructure required dedicating another engineer to constantly tune resource allocation, scaling nodes up and down, and managing cost optimization strategies. That's a US DevOps engineer's salary of around $150,000 to maybe save $20,000 in compute costs. This setup required 85% of deployments go through their DevOps team, creating a bottleneck that slowed critical logistics updates. Why? Jenkins required the DevOps team to create new deployments and update build processes. Developers couldn't actually run the build processes inside of Jenkins themselves. They had to request for DevOps assistance for pipeline changes, new project setups, or any modifications to build configuration. They already had one full-time engineer just managing Jenkins and Kubernetes infrastructure. Adding another one for cost optimization wasn't realistic. Finally, this one isn't directly CI/CD related, but their hybrid setup meant their teams and their development tools were disconnected from planning workflows in Jira Cloud. This means developers were frequently context switching. Planning, code, and CI/CD were all in different tools, and admins were managing users and permissions for each one of those tools. They wanted to simplify their stack. The decision came down to three key factors. First, cost efficiency. Instead of paying for idle infrastructure, they'd pay for only actual usage. The included minutes in their plan covered baseline usage and only paid for additional minutes when demand spiked. No more paying for servers sitting idle 60% of the time. Second, operational simplicity. Instead of managing 20 always-on nodes, they get elastic scaling that matches their actual usage. They didn't need an admin managing and maintaining all these nodes and plugins that they had. Third, bringing the code and CI/CD into the same platform as Jira Cloud would drive developer productivity. Smart commits automatically transitioned issues through workflow states, deployment tracking appeared directly inside of Jira issues, and build statuses sync in real time. Teams get full visibility into their CI/CD pipeline directly from Jira tickets. Developers get more autonomy with CI/CD because they wouldn't need DevOps approval for every single change. Once they saw the value and decided to move, we started discussing migration strategy. There were two approaches we considered: lift and shift or phased migration. Lift and shift means moving everything to the new system at once, exactly how it is, without making changes along the way. We decided on a phased migration approach because development workflows supporting real-time customer operations, from logistics tracking, delivery updates, warehouse management, they could not risk service interruptions. While lift and shift works for simpler migration, their critical pipelines required a different strategy. A lift and shift would force their teams to adapt to everything at once, potentially breaking workflows that directly impacted customers. The phased migration approach we recommended let their team adjust gradually while maintaining these essential services without interruption. Let me walk you through our 5-month progressive strategy for handling both repo migration and pipeline conversion. Month one was all about assessment and cleanup. We started with critical housekeeping that most teams skip. We audited 95 repositories and discovered only 40 of which had active build processes. Think about that. Over half of our repos were dead weight. We then consolidated 12 different pipeline patterns down to 6 standard templates. We retired 8 redundant Jenkins jobs and also merged duplicate workflows. This cleanup cut our migration scope by 58% and reduced our ongoing maintenance burden. Here's what we've learned from multiple migrations. Jenkins accumulates unnecessary configurations over the years. Most organizations have similar tech debt. Clean it up first, and migration becomes much simpler. Month two, we ran a pilot with 5 low-risk warehouse management services. These were important enough to be real tests, but not critical enough to cause major problems if something went wrong. This pilot proved our approach worked and gave us the confidence to move forward. Months 3 and 4 focused on customer-facing systems, specifically tracking and delivery services. These were our critical systems, so we moved them carefully. We validated each migration thoroughly before moving to the next one. Month 5 wrapped up the remaining repositories and we decommissioned the data center. Every wave followed the same pattern. Migrate the repo, convert the pipeline, validate everything worked completely, then move to the next one. We kept parallel systems running the entire time. The result was 0 downtime during the entire migration. The phased approach had another benefit. Teams learned incrementally. We trained 20 development leads who became champions within their teams. They helped their colleagues adopt the changes gradually. No one faced a massive shift overnight. The outcome speaks for itself. Smoother adaptation, fewer support tickets, and teams maintained their productivity through the entire migration. Let me show you an example similar to what our logistics customer was dealing with. Like our logistics client, this Jenkins setup required 4 different plugins for just basic build capabilities. These aren't application features, they're infrastructure add-ons for standard tasks. You want to use Node.js, you have to install a plugin. You want security scanning, another plugin. AWS deployment, yet another plugin. Each plugin has its own update cycle, its own compatibility matrix with Jenkins versions, and its own security vulnerabilities. When Jenkins updates, plugins can break. When plugins updates, other plugins can break. Our client had one engineer spending a significant amount of their time just managing this plugin ecosystem. With Bitbucket pipelines, these capabilities aren't plugins, they're called pipes, which are really just pre-configured Docker containers that run specific tasks. The difference is that you're not modifying Bitbucket itself, you're just calling a service that does the work and returns the result. You can try to think of it this way. Jenkins plugins are just like modifying your car's engine to make it do new things. Pipes are like calling an Uber. The service just works. When Uber updates their fleet, you automatically get the improvements. For our logistics client, this eliminated an entire category of maintenance work. No more plugin compatibility matrices, no more Jenkins restarts, no more which version of Node.js plugin works with Jenkins 2.387. Just write your pipelines and go. That's why DevOps engineers could stop being Jenkins administrators and start being a platform engineer. Let's dive a little bit deeper. On the right here, you can see the Jenkins file that's requiring multiple plugins. For example, you can look at the Node specific Node.js plugin. We also have SonarQube plugin, as well as the AWS plugin. Each of these requires a plugin installation. And essentially, this whole Jenkins pipeline deploys a Node.js application. It runs the tests, performs security scanning, and deploys to AWS. On the left, you can see how we're able to simplify this in Bitbucket pipelines. There's no plugin management at all. Actually, Node.js is just part of the Docker container. And also we have those built-in npm commands, npm CI, npm run build. So it's much easier to maintain the Bitbucket pipeline and has much fewer lines. For example, on the right, we have around 58 lines of code, which is condensed into 19 lines of code on the left here for Bitbucket. And it's much more readable, the Bitbucket pipeline. For example, in Jenkins, we have to define those convoluted staging definitions. And it has a complex nested structure. On Bitbuckets, we just have the simple step definition, and much more easy to read and much more easy to maintain as well. And Bitbucket files, there's no plugin imports at all or tool installations. Remember, everything just works within the Docker context. So you can see how managing a Bitbucket pipeline is much simpler than managing the Jenkins pipeline as well. Just an additional benefit. Now, giving developers more autonomy sounds great, but we needed guardrails. So the organization implemented specific policies to maintain code quality while enabling self-service. Let's start with branch restrictions. We protected main branches from direct pushes. Every change had to come through a pull request, no exceptions. Only designated release managers could merge to production branches. The simple rule prevented accidental pushes to production and kept our main branches stable. For PR approvals, we made reviews mandatory. Every pull request needed at least 2 developers to review and approve before merging. This wasn't about slowing things down, it was about catching issues early when they're cheap to fix. Environment separation became critical. We set up clear pipelines for dev, staging, and production, each with different permission levels. Dev deployments were completely self-service. Developers could push whenever they needed. Staging required team lead approval. Production needed DevOps sign-off. This gave teams the speed where it matters while maintaining control where it counted. We also implemented merge checks and comprehensive audit trails. This system enforced successful builds and passing tests before any merge could happen. Branches had to be up to date with main. Every action was logged, so internal audits could track who deployed what and when. This transparency helped with both troubleshooting and compliance. Security scanning was a non-negotiable. We integrated sneak scans into every commit. Critical vulnerabilities blocked merges automatically. Dependency checks ran in the background, flagging outdated or vulnerable packages before they became problems. Developers fixed security issues as part of their normal workflow, not as a separate security exercise weeks later. These policies weren't bureaucracy, they were automations that let developers move fast without breaking things. Moving on to impact. All of these changes resulted in improvements across key metrics as well as developer experience. Development frequency doubled because developers can now deploy directly to dev and staging environments without waiting for DevOps. Previously, even deployments to dev environments required DevOps involvement. Now, dev deployments are completely self-service and staging only needs team lead approval. Production still required DevOps sign-off, but with automated checks and clear visibility, approvals happened much faster. Pipeline setup dropped from 90%, from 5 hours to 30 minutes. Developers could create pipelines themselves without involving DevOps. No more waiting to have DevOps configure Jenkins jobs, manage plugins, or set up build agents. Teams simply imported standardized templates into their repos and got started immediately. What used to require DevOps tickets and multiple back and forth conversations now happens in minutes. Build failure also improved significantly. When builds failed, developers could see logs instantly, rerun specific steps, and debug their own environments. Previously, they'd file a ticket with DevOps, wait for access to Jenkins logs, then iterate through fixes. Now they own the entire process. The bottom line is that $47,676 in annual savings from Jenkins infrastructure alone, no paying for idle servers. And beyond this, they dramatically improved developer experience, and DevOps engineers who previously were managing the idle nodes now focus on strategic platform capabilities, building reusable components, and improving developer experience rather than maintaining infrastructure. Finally, I wanted to share some common myths that come up when we talk to teams about moving from Jenkins to Bitbucket pipelines. First, people worried that distributed ownership creates chaos. They imagine that every team doing their own things with no standards or control. But here's the thing that we found: standardized templates actually kept everything consistent. We created a template repository with pre approved pipeline files. Developers imported these directly into their repos. This gave teams autonomy while maintaining our standards. Second concern was that self service will hurt code quality. Teams assumed that giving developers control means losing quality checks. The opposite happened. Bitbucket's built-in guardrails actually improved our quality metrics. Merge checks enforced code reviews and testing requirements automatically. Nothing reached production without passing these gates. Third was that developers shouldn't own deployments. But think about it. Who knows the code better than the people writing it? These developers were already deploying their code locally. They understood the build process and deployment requirements. When issues came up, they could identify and fix them quickly. They optimized build times because they felt the pain of slow builds directly. Finally, teams worry that migrations will disrupt delivery. We used a progressive rollout strategy. We started with low-risk projects, learning from each migration, and gradually moved to more critical system. The result was zero production incidents the entire migration. These aren't theoretical benefits. This is actually what happened when teams made the switch. I'm going to now hand it off to Warren, who's going to walk you through Atlassian's developed Docker-based migration tool that converts Jenkins files to Bitbucket pipeline YAML files for you.
Wow. So they converted 200 developers and 95 repositories from Bitbucket Data Center and Jenkins to Bitbucket and Bitbucket pipelines. That's a ton of work. At the beginning of the year, Atlassian released a migration tool that could help with this. It converts Jenkins files to bitbucket-pipelines.yml files. If the tool had been available when you guys did this for migration, it would have been a lot easier. Luckily, all future migrations will benefit from this tool. Okay, I'm going to show you folks how you can use the Bitbucket migration tool to convert a Jenkins file to a bitbucket-pipeline.yml file. And to do that, we're going to go to a repository I've got set up that's attached to Jenkins. We're going to make a quick change in there just to see that the Jenkins file actually works in Jenkins correctly. Then we'll use the migration tool to create a bitbucket-pipeline.yml file. And then we're going to push that file up to Bitbucket, and we'll see the Bitbucket pipelines kick off and run that code. All right, I'm in my demo repository here. We can see that we've got a backend directory, a front-end directory, a Jenkins file. Let's take a look at that Jenkins file really quickly. So it's not exactly the most complicated file, but it's also non-trivial. It does multiple things, uses multiple Docker images. We've got a Maven Docker image, and we've got a Node.js Docker image. It does some commands. So I'm going to make a super trivial change to the README just to kick off the pipeline. And then we'll do a git add, a git commit, and a git push. So this is going to push up to a repository in Bitbucket. Now we're going to jump over to Bitbucket and take a look. All right, so here's our repository. We check out commits. We've got a couple commits. We go to pipelines. We can see that there's no pipeline running. So the last pipeline ran like 20 minutes ago. However, if we jump over to Jenkins, we can see that we do have a pipeline running. And this was kicked off by our change. If we drill in here, we go to console output, we can see that it's actually running and doing a bunch of stuff. So if we wait for a little bit, this will finish successfully, just like the last ones. All right, now that's done, let's take a look. go to our console output, let's drag to the bottom, we can see pipeline finished successfully. So now what we're going to do is we're going to go back to the terminal, and we're going to use the Jenkins migration tool to create a bitbucket-pipeline.yml file, and then we'll do another push up to Bitbucket. And when that happens, the Jenkins will still kick off because we haven't turned that off in any way. But because we've added a bitbucket-pipeline.yml file, Bitbucket pipelines will also run, and we'll get to see the steps that have been created automatically by the migration tool. So let's head back to our terminal. All right, we're going to run our tool now. The tool is created and presented as a Docker image, so you can Docker pull this and then use it. And the command has some basic parameters in it. Basically, you pass it a path to your Jenkins file and a path you want the bitbucket pipeline.yml file to be written to, and it creates it for you. So we're going to hit enter. And it's done. Now if we do a git status, we can see we've got two new files, a .bitbucket-pipeline-config and a bitbucket-pipeline.yml file. Let's take a quick look at that bitbucket-pipelines.yml file. So simple file, has some steps, uses the same Docker images that we saw before, runs basically the same commands. So now if we do a git add ---- all and a git commit, and a git push, we're going to jump back over to Jenkins first, and we'll see that we still have a pipeline kicking off and running. And then after that, we're going to jump to Bitbucket, and we'll see the Bitbucket pipeline is now also running because we've added a bitbucket pipeline.yml file. All right, let's back up a step. And we can see we've got a new pipeline kicking off. We drill in, we can see that it's working and doing some stuff. I'm not going to sit here and watch this thing run to completion because it's the exact same run we just saw. But now let's jump over to Bitbucket and we'll take a look at that. And in Bitbucket, we can see we have a pipeline kicking off now. If we drill in, we can see that we've got test backend, test frontend, both steps running in parallel. And once these two steps complete, we're going to do build backend and build frontend, also running in parallel, and then we're going to deploy. And this mirrors the structure of the Jenkins file exactly. And we're done. Things worked. So the migration tool successfully created a bitbucket pipeline.yml file from a Jenkins file. The Jenkins file works in Jenkins and does all the stuff it's supposed to. And the bitbucket pipeline.yml file does the same things in Bitbucket. So now let's jump back over to our slide deck real quickly. If you want to learn more about this tool and how to use it, please scan this QR code. There's a set of instructions and a bunch of links that'll help you out with more information. All right, I'm going to hand this back over to Ash now to carry on. Thank you.
Thank you, Warren and Riley, and hi again, everyone. Now, the case study we just went through was from about a year ago. Since then, we've invested a lot more into Bitbucket pipelines. Now, besides the migration tool that Warren just reviewed, I want to share three key investments. First, in the case study, we saw Sneak being used for security scanning. Since then, we've launched 3 native security scanning pipes that you can use as well for no extra charge. We have a secret scanning pipe that checks for over 400 types of exposed secrets. If you insert the pipe as shown here into your script, you'll get access to a report which identifies any secrets exposed in your code, which you can fix before you deploy. Similarly, we have a dependency scanner, a pipe which checks all your open source libraries for any vulnerabilities within them. And we have an infrastructure as code pipe, which checks for security risks in your config files. These 3 pipes are maintained by Atlassian, so all you have to do is add them into your script and run it. Next, Riley talked about how developers were able to fix build failures much faster in Bitbucket pipelines. This was because developers can see pipeline status in real time and can act faster on it. Now, to make it even simpler, we recently shipped an AI-powered pipeline troubleshooter. When a step in your pipeline fails, the pipeline troubleshooter scans your build logs and summarizes what needs fixing. So if you're spending a lot of time scanning through your logs to figure out what broke your build, this will save you a lot of time. And finally, I wanted to highlight our dynamic pipelines functionality. With dynamic pipelines, you can set and enforce CI/CD policies across your organization. When you move from a central system like Jenkins to Bitbucket pipelines where developers have more autonomy, you may want to set some global CI/CD policies to ensure code quality. For example, if you had a policy that every pipeline should include a secret scan, you can create this, and once you set this policy, if a pipeline does not contain a secret scan, it gets dynamically inserted into the pipeline at runtime. This means that as a developer, you don't have to worry about shipping code that doesn't meet your internal code policies. And the same for platform teams. You can be assured that all builds meet your code policies. So as next steps, I want to share a DevSecOps demo that Warren recently created. In this demo, he walks through in detail how Bitbucket Pipelines works with the Atlassian stack. You'll find a link to this in the resources section. Next, if you haven't already, I would encourage your teams to try a few builds on pipelines. If you're using Bitbucket Cloud already, you have build minutes already included in your plan, so you can get started right away. And if you're currently using Bitbucket Data Center, we have a cloud migration trial available, which gives you a free trial of Bitbucket Cloud Premium for the remainder of your data center license. There's a link in the resources section with more details on this as well. And if you're looking for help in implementing your migration, we have a link to our partner directory, or you can connect directly here with Riley from Atlas Bench as well. All these links and the webinar recording will be shared with you via email in a day or two. So with that, let's move on to the Q&A.